What are we doing?
I'm thinking we should look at, let's look at 34. 34 is a good kind of summary of like everything, the second half of this problem set. Because it's asking us to write two integrals. It says we don't have to evaluate them, we just have to write the integrals, okay? So, what does this first curve look like? It's the last problem.
Thank you.
So it says, consider the region bounded by this curve, and the x-axis. So what does this graph look like? And then it says we should be able to make two equivalent integrals, one with respect to x and one with respect to y, that both likely capture the area. So let's see. Not obvious what that looks like, right? Who can name just a point though on this curve?
0, 0.
Nope, because if you, well, it's a good start though. Can you plug in 0, 0? You'd have 0 on the left side, and you'd have square root of 4 minus 0 on the right side, but 0 doesn't equal 2. But that gets us, I certainly could have x equals 0 if y is what?
2.
2. No, 4.
Well, 4, 2, 1.
Bruh.
God, that was. I was thinking of the last thing.
Does everyone understand that?
I know where you're going.
Now, here's another thought. Can y be bigger than 4? Can y be greater than 4?
No.
You have a negative under the square root, so that tells us this is going to go down, right? Can x be negative? Okay. How about if y is 0? What's x?
2.
2. Do we know what the graph looks like yet? If not, maybe one more. Is there a negative y value that's, or even you can say like, let's say y was 3. That gets us an easy number, right? If y is 3, x is 1. So 1, 3. Anyway, so hopefully you get the idea now. But here's just something to think about. Like, what if you graphed y? This is a lot simpler. This one I would hope is fairly automatic for you. If not, you might need to brush up on your parent functions and transformations. But that would look like that. Therefore, when you swap the x and the y variables, it's, who remembers this one? This guy is a reflection of this guy over what? Y equals x. So if I graphed y equals x and reflected it over, it would look like that, right? So that's what happens when you swap the x and y. Anyway, we're not doing that. So. Okay, the other one is y equals 3x. That one, hopefully pretty easy, right? It's just a slope of 3. So it has a point, say 1, 3 on it. So there's definitely a noteworthy point, the point 1, 3. And then the x-axis looks like this. So the region bounded by those 3 curves, what do you guys want to do first? You want to do the with respect to x first or with respect to y? With y? Okay, so that means we're going to slice it this way. Okay. Let's examine one little slice. How about right here? That slice is looking pretty good. How thick is that slice? dy, a tiny change. I'm gonna zoom in on that slice here. This is my horizontal slice. The thickness is dy. Okay. Now, what's the width of that slice? It's the difference between this point's x value and this point's x value. Are there any questions on that idea? You sure? So the width of this is the difference between this x value and this x value.
Okay.
So what's the x value of a point on this curve? that. X equals this thing. So it would be the square root of 4 minus y minus, what's the x value of a point on this line?
Minus 3x.
1/3 of y.
Oh, that's right, we're doing respect to y.
Do we feel okay about that or no? This is a good time for questions if there's anything unclear.
That makes sense.
Notice everything is in terms of y.
Yeah.
So this integral is going to be the integral of this quantity, square root of 4 minus y minus 1/3 y times dy. Let's get our bounds correct. What kind of numbers need to be the bounds if these are all y values? If these are all y values, right, if this is all y, these need to be two y values. What do you say? 0 to 3. Do we understand why it's 0 to 3? Because that's the lower y value is 0 and the upper y value is 3. Okay? So this expression represents this area, the shaded area. All right, we got to do it again. Well, okay, let me actually pause here. So what are we going to do next? What's the second part of the problem?
Gotta get that other region.
Hold on, what Aiden?
Rewrite it in terms of that.
Yes, so this is the constructing the integral with horizontal slices in mind gives us this integral with respect to y. And so the other part of the problem is write an equivalent integral. That's the exact same value, but in terms of x. Okay, so same picture. 1, 2, 3, 4. 1, 2, same points, everything's the same. But this time, I want to slice it this way. We feel okay about that? Does anyone see what we're gonna have to do on this to make it work?
Your x is in. You're gonna have to.
No limit needed.
There's something to do to your x value is gonna be 0. Like,
There's gonna be, well, that's a relevant x value 0. Here's a hint. This 1 is definitely relevant. Excellent, good, perfect. There needs to be two integrals.
Can you elaborate on that why?
Because remember, you always go top minus bottom, right? So between 0 and 1, it's this straight line minus 0.
Yeah.
And then from 1 to 2, it's this curve minus 0.
Okay.
Right? There's actually two separate things you got to look at. So let's do them both. This one's actually turned out to be a little bit easier.
To like make it speed up, can you just get the area of the straight line from 0 to 1?
That is just a triangle, yeah. But just in the interest of making it like, you're totally right. Yeah, the area of that triangle is 3 halves. But, so you go to integral from 0 to 1. So between 0 and 1, each little slice is just this y value minus this y value. So it would be 3x minus 0. And we're going to add on the integral from 1 to 2. Right? But you see the slices now are this curve minus 0. But wait a second, what's the y value? If I pick a random arbitrary point on this curve, keeping in mind that it's all about x's now, what's the y value of this?
Negative. Is it? Yeah, negative x.
Yes, maybe? So I rearrange this. So I went, well, this equation tells me the relationship between the x and y value of any point on this curve. So if your x value is the square root of 4 minus your y value, I can square both sides and rearrange and say, okay, I guess that my y value is just 4 minus my x squared value. Why did I want to do that? Well, because I need x's in here, right? Do we, I don't know, do we feel okay or? How can I check my answer?
Desmos.
Mr. Computer. O great machine, who knoweth all.
Wait, where does the x squared come from? The 4 minus x squared.
So this is the curves equation. So I squared both sides. Well, the first thing is you have to, the most important thing really is to understand the necessity of doing this. You have to understand that, well, I need to do a y value minus a y value to analyze that slice. So I have to ask, how do I write the y value for a point on this curve? I need to rearrange the equation. So,
Oh, Mr. Computer.
integral from 0 to 3, I think I can put y's in. Square root of 4 minus y minus 1/3 of y dy. 3 and 6 apparently. And I can also go integral from 0 to 1 of 3x dx plus the integral from 1 to 2 of 4 minus x squared dx. Oh no, not that. And then, oh, beautiful, lovely. I can also do stuff like check to make sure that everything went in correct. Okay, that looks good. And there you go. So everything seems to be checking out fine.
Is there any way if you just put like x or y equals 0 or whatever in there, could Desmos find that area? Just out of curiosity.
Well, you can do stuff like, I can define a function as f of x and a function as g of x, and I'll just type in integral of f of x minus g of x dx, and it'll do that. But it's not, it can never just like detect a closed region and then find the area. You gotta be a bit more specific about what you're asking.
Mr. Hall. Mr. Hall.
There you go.
Have you done fights around the Cardi Whitefish Lake and done that loop?
Wait, what is it?
So you start like at